Now I try to explain you determination of the spring constant K of a spring using the principle of moment. Determination of the spring constant K of a spring using the principle of moment. Principle of moment means what? In rotational equilibrium, sum of all clockwise movements is equal to sum of all anticlockwise movements about the same pivot. So there is a principle of momentum. So sum of clockwise and anticlockwise it is the same. So that is the principle of momentum. Principle of moment. So what is the aim of this practicals? To apply Hooke's law and the principle of moment to the practical situations. To apply the Hooke's law and the principle of moment to the practical situations. So there is giving some situations here. So theory they are giving. So there is a scale, pivot, spring they are giving here. So first we will see what are the apparatus we need. So we need apparatus. One, retard stand. So there is a stand. We have the stand is there. So one clamp. So there is a clamp I fixed here. So there is a bobs. Boss. There is a, this is the boss. There is a clamp. This is the clamp I fixed here. And one spring. Where is the spring? So there is a spring. Next string. So string also it is attached into the spring. There is a string. 1 meter rule. So 1 meter scale is here. There is a 1 meter scale is the here. There is a 1 meter scale. And 100 gram mass. So there is a 100 gram mass. So triangular glass prism or small triangular pivot. So triangular glass prism. This is the triangular glass prism. So 30 centimeter ruler with millimeter scale. 30 centimeter ruler with millimeter scale. So access to the electronic balance. So we have, you see here, there is a first method. So first method, there is a scale is there. The scale is there. Center is pivot is there. So what we do? So it is be balanced. Center of gravity. Where it is balanced. That is we want to find. So consider there is a scale. So where it is balanced. So we will move like this. So any one point it is a balanced. So similar way it is a balanced. So that point we will note it. Here that point. Here the small scale for explanation I am giving the small scale here 25. Here we note it. Then afterwards here we attach it to the 100 gram mass. 100 gram mass we want to attach it here. So here we want to attach it. So the similar way I already attached here. So then the place 100 gram mass over center of the rule. So where is the center of the rule? You placed here. Okay. That is still balanced at C. It is want to still balanced. When you are keep it there, then it is be balanced. You see, it is a balanced. See here, it is balanced. If you are keep it there. Okay. This is setup. There is the pivot is there. There is a mass is there center. Here spring is there. There is a stand and a clamp. Everything is there. The same setup I arranged here. So see here. There is a. So here spring is there. So here spring is there. Spring. There is a thread scale and also here there is a mass is there. Then I attached here likewise. You see here that setup. In this way you arrange. Now we will see the calculations. So already we have seen this one. So this calculation we will see. So before here what they said. So 100 gram mass attached to the midpoint of meter rule. 100 gram mass it is attached to the midpoint of the rule. Already I attached. Okay. So this makes rule artificially heavier. So it is a makes. So if you attach this one, it is a makes it is be heavier. This heavier it is give to the here. This heavier mass gives to the some weight. So it is be elongate. So there is a original positions. There is a unstitched length. When we are apply this one a heavier mass, when I remove my hand, it at the time it is be expand. So heavier mass gives elongations. So you want to find elongation. That is why we are add here a little 100 gram mass. Okay, then it is explained you. So combined mass of rule and 100 gram. So combined mass of rule. This rule, the ruler, and this mass. So both is mass is 218 gram. So I measured here. So after that we will see this calculations. So the clockwise momentum. So before we are see this one, the principle of movement rule. So there is a clockwise movement. So clockwise movement. So K means what? So there is a K means this is the constant value. So how much it is a stress is directly proportional to the strain. How much it is a strip? How much weight is there? So stress is directly proportional to the strain. So stress is equal to, if you apply, then it becomes constant. Constant K equal to strain. K equal to stress by strain. It becomes likewise. So this is the K value. So how much it is the stiffness is there, you will find. So that is the K. So this is the K. And what is the L? So L minus L naught. L naught means what? L naught is the unstitched length. So this is the unstitched length. So it is not stitched, it is unstitched length. How much is the unstitched length? We will measure. So that is the L naught. That is the original positions, otherwise unstitched length. So L means stitched length. Suppose we are apply some mass here, that time it is stitched. How much it is stitched? We want to measure. That is the L. So there is a K, L is the stitched mass, stitched, it is a unstitched length. This is the stitched length, it is unstitched length. So L is a stitched length minus L naught is a unstitched length. So next X. What is the X? X means from pivot to, from here to, so pivot to here, this length. How much distance is there? The scale length horizontally. How much distance from here that thread to that pivot? How much distance is there? We will measure. So that is so there is from pivot to how much distance? From here it is the 4. Pivot nearby it is 4 is there. It is 4. From here to, so there is a 97. 4 to 97. So we want to find this X. This is the X value. Okay. So now anti-clockwise movement. So there is a anti-clockwise movement. This is the clockwise movement. So anti-clockwise movement is a mg. So there is a mass, gravity acts downward. Okay, there's a mass, gravity is acted downward. So there is a m and a g. So and then there is a mg x minus c. So x means we know. So distance between from pivot to x means from pivot to this thread, where it is this thread is noted, that point from here to here is the x distance. C means c distance is from center of mass here, from here to here. How much distance? From here to here, from here to this center of mass. Where it, how much distance it is be center? It is represent. It is a c. So now you know. So mg x minus c. So from x distance to minus c means we will find it the center of gravity. How much is there? So okay. So I think you are understand something here. So anti-clockwise direction. So both is equal. So anti-clockwise direction, clockwise direction, it is be equal. That is the law. According to that law, we will see this one. So see here, mg x. There is a mg x minus c equal to k l k into l minus 0. This is both side I write likewise. When the rule is balanced. When rule is balanced, if it is balanced means we will write likewise. Next one, this formula you multiply this one. mg into x, mg x, mg into minus c. So mg minus c minus mg c. Okay, then here k is there, here x is there. You write kx into l, k lx, kx into l, k lx. So after that kx into l0, kx into l0. So minus. So you write like this. I know. I hope this step you understand something. Okay. So then you see here. So what we need? We need L, because how much stitched length we want to find. So L means stitched length. L not means unstitched length. We want to find stitched length. So L we want to take it. So that is why KLX equal to, this is comes KLX equal to minus MGC. They are written likewise. Next one MGX. Here minus is there. The minus, if it goes this side, it is a plus. So plus K L naught X. Okay. So after that we need only L only we need. So we don't need for KX. So what we do? So we divide by KX. If you divide by KX all the side, we will find it L. So if you want L means we will divide by KX. So you see here KLX by KX. So we cancel each other. KX. This is the cancel. Remaining L only is there. If you are one side multiply means both side we can multiply. Then only it is equal. Here KX is there. Here MG is there. We cannot divide anything. So after that here MGX. You see here MGX. So here MGX I wrote here KX. So KX means the X it is be cancelled. Remaining K is there. Here you see KL naught. There is a X. KL naught X. See here KL naught X. Here KX. So KX it is be cancelled. Now you see here L only is there. L only. L equal to MGC KC. L equal to minus MGC KC. This minus MGC KC. Remaining here plus mg by k. So remaining mg by k. X it is be divided. So plus mg k plus L0. That means, so this is the mg by k. This step. So after that here kx it is be cancelled. Only L naught only is there. So L naught plus L naught. Okay, this is the step you write down. So here you see this step L naught. You see here, you apply formula, then you can understand this one. A divided by kx means you divide all the kx, then you got it this one. Suppose if you are I mixed here means you can understand. So L equal to minus mg k. Here mgc kx is there. Here mgc k. X will take it out. If you take it out means we write 1 by x. Is divide is there. So 1 by x. And plus mg k plus L naught. We write likewise. So after that mg k. This mgk we write into the a. Here a equal to c equal to mgck. So mgck, instead of mgck I write here a. Remaining what is there? X is there. So I write here. Plus here b, you see here b equal to mg by k plus L naught. Mg by k plus L naught. This is the b. So instead of this one I write here. So L equal to minus a by x plus b. Using this formula we will find it to the stitched length. Okay. Now we will take the reading. So reading what they are giving here, xm. X means distance in a meter they are giving. So distance, what x means what? So x is from a pivot from here, this distance to this thread. How much distance? So from this distance. Okay. So you see here you see there is a 5. Here you see the pivot is the so here the 5. From 5 to here is the thread is hanging here 97. Okay, x equal to how much distance? From 5 to 97. So using the calculator, so 97 minus 5 equal to 92. So here I write here 92 centimeter. So 92 centimeter, if you are convert into the meter, what we do? So divide by 100. So if you divide by 100 means 0.92. So 92 meter. 0.92 here meter, here also meter is the meters cancel. Only I write 0.92. So x value I noted 0.92. So here length. So length means what? The spring length. So original position is 2 centimeter. So now it is elongate. So now it is, we are apply the mass. Now it is elongate. So how much it is elongate we want to measure from here. See. From here to there is nearly 6. It is come 6 centimeter. So length is 6 centimeter. So 6 centimeter it is elongate. 6 centimeter. So if you write meter means we wrote here 0.06 meter. 0.6 meter if you write likewise. Here 1 by x means what? 1 by x. So 1 by x 0.92. So why we want to find 1 by x? Why we want to find 1 by x? You see formula here L equal to A by X. X is a down is there. So X value we want to change 1 by X. So that is why we are find it here. If you want to find stitched length means we need not X, we need 1 by X. So here X is there. So we want to change into the 1 by X. 1 by X is so there is a 1 by X is 92. So there is a 92. 1 by X means 1 divided by X value 0.92. One by 0.92. How much this comes? 1.086. There is a 1.086 meter. So in this way again we want to find now it is a 5 is there. So here 5. I moved this pivot from 5 to 10. So now this pivot is shows the 10. It is B 10. Now I moved 5 centimeter. I moved ahead. At the time, how much it is elongation? That is we will note it. Okay. So distance is how much here? Here is properly here 10. Here is 10. Here is 97. Okay. Now 97 minus 10. How much? That's the 87. So next is 87 centimeter. So we want to change into the meter. So meter means divide by 100. We can get it 0.82. So how much length? So we will see how much length is there. Now you see here. .5. It is a 5.5. So noted here. Length is a 5.5. So we will write it here centimeter. So 5.5 means if you divide by 100, we can get it 0.055 meter. So then afterwards 1 by x 0.82. So how I take it the reading? So here 1.21. So if you divide 1 by x is the 1.87. 1 by 87, not 87 is centimeter. 1 by 0.82. So 1 by 0.82. If you divide, you can get it 1.21 meter. So 1.21 meter. The similar way you take reading, 6 reading you take it. Then only you can draw the graph. You can draw graph. So the similar way you take. So afterwards what you do? Just you move. There's a 15, 20, 25, 30. If you move like that, the elongation it is decreased. First it is 6 centimeter. Next 5.5 centimeter. Then also 4, 3. It is going likewise. Okay, it comes original positions afterwards. So in this way, you will check how much elongation is there. So next, so gradient. So gradient means you know. So you draw graph. After that, the graph value that you take it, this one, so there is a 1 by x. There is a x-axis. 1 by x is the x-axis. L is the y-axis. You draw the graph. Okay. Then you draw graph. You get one straight line something. then you take the slope. Then, so x1 value. So here y2 minus y1. Y2, you take the 2 points, y2 minus y1, y2 minus y1, x2 minus x1. You divide, then you get it some answer. So gradient equal to mgc k. M value, you know how much mass, 100. Gravity 9.8. C from center to that length, it is a 50. So already we find 50.8. The center, how much is there? So 50.8. Okay. So you find the k means you find it this value, gradient value. Then k it goes here. It comes here. Then you can divide. So all the value you can get it. So y intercept L naught. L naught value you know 2 centimeter. So unstitched length is 2 centimeter. Unstitched length means this is when if you had, it is a stitched. This is unstitched length. Okay. Now you measure this one. How much length is there? This one. This how much length? So you find this is L naught. So this is the L naught. You apply that value. The 2 centimeter means you 0.02. It is comes 2 centimeter. If you convert into the meter. So and this value everything you know. So you will find it. You do like that the graph. I hope you are understand something this practicals. So what is this practical? The determination of spring constant K, the spring using the principle of momentum. Principle of moment. So okay, you do likewise, you can get it answer. So I hope you understand something. Thank you.